Bueno, 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 a ver si se escucha. Parece que sí. Va un poquito mal, como siempre OBS, pero bueno, pero parece que se escucha. Buena gente, ¿qué tal? Bienvenidos todos a un nuevo directo de lanzamientos espaciales. Bienvenidos al lanzamiento de Falcon 9, el lanzamiento de la misión IMAP al punto N1 de la Tierra Sol. Por cierto, me siento un poco raro viviéndome 3 veces en la pantalla, que bueno. Eh, o, o sea, aunque bueno. Bienvenidos todos a un nuevo directo aquí en el canal. Antes que nada, espero que OBS hoy funcione bien. Hoy el PC se levantó de mala manera. No quería encender, después me crashó Windows. Aunque bueno, a ver si nos deja disfrutar de este lanzamiento. Que bueno, será como era acá, en 17 minutos y medio, un poco menos. Por cierto, vamos a pasar ya a vistas bueno, del vehículo.
Little more than 17 minutes.
Vale, ahí tenemos vista de la carga de propelente en marcha. Vamos a ponerla en la vista del directo oficial de SpaceX. Ahí tenemos vista oficial del directo de SpaceX. Nos encontramos a menos de 17 minutos del lanzamiento. Recordemos que en menos de 16 minutos iniciaría la carga de propelente en la segunda etapa. Eso sería ahora en 45 segundos. Esta es una misión de más o menos 1 hora y media de duración, por lo cual A ver, después del apagado del motor de la primera etapa y hasta el encendido del motor de la segunda etapa, yo me iré un rato del directo, pero igualmente estaremos en vivo. Vosotros ahí estamos viendo las cargas útiles de que viajarán en esta misión, que son 3 satélites. Básicamente tenemos IMAP, un satélite de la NOAA, y el otro que no me acuerdo, que se llama Gride, que ya se los comento bien. Aunque bueno, nos encontramos a 16 minutos para el lanzamiento. Ahora mismo debería estar iniciando la carga de propelente en la segunda etapa. Recordemos que la segunda etapa no se reutiliza, es la única parte de Falcon 9 que no se reutiliza. Después la primera etapa y cofias sí son reutilizadas. La primera etapa B1096, este será su segundo vuelo. Primer vuelo fue la primera misión de Kuiper a bordo de Falcon. Y bueno, este será el segundo vuelo. Intentará ser recuperada sobre la barcaza JRTI. Su vuelo anterior fue recuperada sobre la barcaza ASO. Y bueno, y después tenemos las dos unidades de la cofia, que no tengo el dato de cuánta reutilización está teniendo el día de hoy las cofias. Aunque bueno, nos encontramos a menos de 15 minutos para el lanzamiento, despegue desde la plataforma SLC, SLC no, perdón, LC-39A, en el Centro Espacial Kennedy, ahí en Florida. Ahí tenemos vistas del vehículo. Por cierto, el próximo evento será el Engine Chill, o más conocido como enfriamiento de motores. Esta misión viajarán 3 satélites. Bueno, el principal, el que le da el nombre de la misión, IMAP. Después viajará un satélite meteorológico. Y también viajará un telescopio espacial en ultravioleta.
Those would carry them from the mobile launcher safely to the ground. All this training helps the Artemis 2 teams plan and understand the timing of events on launch day. That's your Artemis.
Vamos a pasar a la vista de Space Low, que nos está mostrando ahí las distintas naves de que viajarán en esta misión.
About 12 minutes away from launching 3 spacecraft to study space weather and how it impacts us. NASA's Interstellar Mapping and Acceleration Probe, or IMAP, NASA's Carruthers Corona Observatory.
Bien, y aquí la NASA nos está mostrando una animación de lo que será la órbita de los satélites. En el punto L1, recordemos que el punto L1 se encuentra a 1,5 millones de kilómetros de nuestro planeta. Como vemos ahí, el panel está en verde. Nos encontramos a 12 minutos con 40 segundos para el lanzamiento. Este es el centro de control de la misión IMAP.
Yeah, APL built the IMAP spacecraft as well as one of its 10 instruments, and after launch, APL is going to operate IMAP. Now, Kelly, we're still getting some great questions from social media.
Bueno, se acerca el lanzamiento de Falcon 9 en 12 minutos. Recordemos que Falcon 9 es un vehículo de 2 etapas, parcialmente reutilizable. Ya comentamos que se reutiliza las cofias y la primera etapa. Ya comentamos los vuelos que tiene la primera etapa. Vamos a comentar un poquito de datos, como por ejemplo que tiene 70 metros de diámetro, digo 70 metros de altura y 3.66 metros de diámetro. Este vehículo se lanza desde 3 plataformas de lanzamiento distintas, como puede ser en Florida, el S-39A, como es en este caso, es el S-40, o si no tenemos en Vandenberg, es el S-4E, y se está construyendo la plataforma SLC-6, pero bueno, pero esa aún no está operativa, por eso no la conté en la cantidad de plataformas que hay, o sea, que tiene Falcon 9.
It has the suite of 6 instruments, and as compared to Carruthers and the IMAP instrument, which will be gathering more research data in order to better inform how we
Ahora SpaceX, nos está mostrando,
various elements of space weather.
nos está mostrando ahí del encapsulamiento de las naves.
Its suite of instruments are designed to monitor the sun's activities and
From
able
here on
to
Earth,
send that
our sun
information back
looks
to
steady and
decision makers
unchanging.
here on the ground
But
in
close
order
up,
to
it's a
better
dynamic,
protect
active place.
property and infrastructure from the
Loops of
impacts
superheated
of
plasma
Ahí tenemos
volcanic
las distintas
eruptions
características de que hoy.
a steady stream of
negative
Aunque bueno, básicamente,
orbit like
a ver, por hacer un resumen de lo que vamos a ver hoy. Vamos a ver el lanzamiento de 3 naves, básicamente IMAP, Space, Space Where Follow One, no sé si lo pronuncié bien, es un satélite operado por la NOAA, y Glide. O sea, aunque bueno, anteriormente es llamado Glide, pero igualmente se puede llamar Glide al ser el satélite.
Our magnetic field can go
airlines
haywire
also
during what's called a
rely on
geomagnetic storm.
communications
In
that
May
can be impacted by
2024,
a strong
the
solar
biggest
storm.
geomagnetic storm in over 2 decades hit Earth.
Que en realidad no es un satélite, es un telescopio espacial. O sea, básicamente, vamos a tener el lanzamiento de una sonda, como es IMAP, un satélite, como es el de la NOAA, y un telescopio espacial, como es GLIDE. ¿Cuánto por ciento? Nos encontramos a menos de 9 minutos para el lanzamiento,
Satellites in space and astronauts as they head to the moon and Mars.
Kelly, with just 9 minutes away from launch, tell us how much this moment means to you and everyone who worked on all 3 missions.
Right. Yeah, I am just filled with so much gratitude
Just under 9
and so
minutes
much
to go.
excitement
Here's one last
for
image
the
I want to
entire
share with
team,
you
all
all
the
of
teams
those
that
3
really worked
spacecraft before they
here
were
at Kennedy, here at
encapsulated
all the
fully
different
inside
mission
payload
teams,
bearings.
as well as SpaceX.
Y ahí estaban encapsulados
Together.
los 3
So
satélites que
excited
viajarán en
and
esta
crossing my
misión.
fingers and toes, hoping for a beautiful launch very soon.
Getting ready to lift
Absolutely.
off
It's
here in
absolutely
just
going to
about
be a
a
beautiful
minute
launch.
and a half.
Take a look out there, the pad, the clouds, the sunrise in the background.
You can see
So
some of
let
the
us get to
photographers
liftoff.
around
Let
the
us
press
count
site
down
here,
the final
getting
minutes to
their
launch with
cameras
NASA's
and
Daryl Nail
tripods ready
and
to
Norman Phelps here in
capture this
Florida
Falcon
and
9
Amanda
rocket
Years
as it makes
with
its
SpaceX
ascent
in Hawthorne,
toward the
California.
Space Coast.
Let's do
Coming
it.
up in the
We are
next
all ready to
minute,
go.
we should hear a call
We're here inside
regarding
our Mission
the
Director
engine
Center
shield.
at Hangar
SpaceX
AE.
will
You see
flow a
behind us,
small
this
amount
is
of
where
oxygen
all of the
from
management
pumps,
for
helping
all 3
protect those engines
spacecraft
from the risk of
are located.
thermal shock
And it's a
damage
high-level
during startup.
area inside there, but they'll be tracking everything that's happening.
call should happen
And so
right
far,
about
so
to
good.
Mientras tanto, ando buscando por aquí.
so good. I mean, they
Ahora sí.
actually
Aunque bueno,
really
ahora tenemos en 50 segundos el enfriamiento de motores, donde los 9 motores más rápidos de comenzarán a enfriarse en preparación para el lanzamiento.
Also worth noting,
Eso será en 40 segundos.
morning when you unplug your cell phone from the wall, you just detach it from your EGSC there in your wall. That means now that our spacecraft are ready to launch and is ready to do business, just like your cell phone is attached from this wall, ready to do business with you.
last well beyond
2
that,
spacecraft on
the
internal
liftoff
power,
reserves
IMAP and SWIFO.
its
We've heard that call out, SWIFO L1. Carruthers, though, not powered up, so there was no switch for them.
Yeah, Carruthers is powered off during launch, so they're not powered on. So obviously there's no call to be on internal power for them. But this is typical. Some of our launch vehicles launch powered on, some launch powered off. So nothing new to see here.
IMAP is one of the strictest contamination.
Y bueno, justo ahora nos encontramos a menos 7 minutos para el lanzamiento. Inicia el flujo de LOX para enfriar las turbobombas y allí así evitar que, bueno, de que durante el encendido hayan roturas por las altas temperaturas que toma el motor. Aunque bueno, se viene el lanzamiento de Falcon 9 ahora en 6 minutos y medio. Por cierto, en menos 6 minutos finalizaría la carga de R1 en la primera etapa. Así que bueno, ya se completó la carga de R1. Estábamos escuchando. Pero bueno, se viene el lanzamiento de Falcon 9.
And Amanda, you're out there tracking the countdown from your vantage point in Hawthorne, California.
Yeah, that's right. So as we enter these final minutes before liftoff, weather is still looking good. We have a 10%
Por cierto, el audio que estamos escuchando de fondo es el de la transmisión oficial de SpaceX y también el audio de Spaceflight Now. Básicamente el que tenemos más alto en volumen es el de Space, el oficial. Ahora mismo yo puse el de SpaceX. Por cierto, cuando se acerque, o sea, cuando esté en un momento del lanzamiento, suban el volumen al máximo porque vamos a tener muy buen audio del lanzamiento. Es una de las cosas de que me encanta cuando se lanza desde Florida. Tenemos muy buen audio del despegue.
Propellant is intentionally loaded late into the countdown. Colder propellants are denser, and denser propellants mean achieving more performance out of the same tanks. So simply put, the colder it is, the more mass it can move. That's a great sign that we're on track for an on-time liftoff. So if you look
Y ahora se vendrá el Strong Back Retard, que básicamente la torre que sujeta el Falcon 9 se va a retraer 13 grados para dejarle suficiente espacio al vehículo al momento del despegue. Eso será en 6 segundos. Todo continúa nominal, todo continúa según los parámetros esperados. Por cierto, vamos a mostrar esta vista de SpaceX. Ahora vamos a ver cómo esas pinzas que están en la parte inferior de las cofias se empiezan a abrir y posteriormente se va a retraer la torre. O sea, ahí se empiezan a abrir. Se abre primero una, después se abre la otra y posteriormente se va a retraer la torre.
Just heard a great confirmation
SpaceX
there.
launch director checking in with NASA launch manager Dr. Denton Gibson. He gave the go, another milestone working us closer to a liftoff today.
So like I said before, all the analyses, all the work has come to this moment. So kudos to the team for getting through this polls.
Y ahí vemos cómo se empieza a retraer la torre.
Our cosmic carpool taking 3 spacecraft, IMAP, SWIFO L1 and Carruthers on a million-mile journey to L1.
Coming up next in just a few seconds, we're expecting the completion of stage 1 liquid.
Y ahora mismo estaría finalizando la carga en la primera etapa. Ahí tenemos. Se completó la carga de propelentes en la primera etapa de Falcon 9.
Now, liquid oxygen loading has wrapped up for the first stage, which completes propellant loading for the booster. We mentioned these tanks are also
2 minutos con 40 segundos se completará la carga en la segunda etapa y en el vehículo completamente. Y se viene el despegue de Falcon 9 desde, para mí, mi plataforma de lanzamiento favorita de Falcon 9, el LC-39A, desde el Centro Espacial Kennedy.
From there on out, the countdown is fully autonomous. Then just inside of T-2 seconds,
En menos un minuto ocultaremos el timeline nuestro para pasar a tener el oficial de Space. O sea, de por tema de que ahora mismo no está el de Space. No lo está mostrando aún. Aunque bueno, se viene el lanzamiento de menos 2 minutos, se completa la carga de propelentes en el vehículo y se viene el despegue.
Stage 2 LOX load is finished. As you can see, as you look at this rocket, you see the See that burst of LOX coming off the
Se viene el lanzamiento.
line there. Nice little clouds formed when that super chilled liquid oxygen hits this warm Florida air. It's a beautiful morning here on the Space Coast. A little past sunrise. They've closed out the gases at the launch pad, as you can see there. The rocket is super cold, so of course it's condensing the
Se viene el despegue del Falcon 9.
giving off those clouds. We're getting ready to
De menos 1 minuto con 7 segundos. Recordemos que en menos 1 minuto Falcon 9 pasará a tomar control de la cuenta regresiva por sí mismo. Pasará a ser alimentado de sus baterías internas. Eso es justo ahora. Se viene el despegue de Falcon 9.
Right on time. So at this point, the autonomous flight computers have taken over the launch countdown, and stages 1 and 2 will begin pressurizing for launch. Let's listen in.
45 segundos, a ver.
The launch director is go for launch.
Go for launch. Tenemos go para proceder con el lanzamiento. Se viene el despegue de Falcon 9. Se viene el despegue.
30 seconds.
30 segundos y contando. ¿20 segundos?
T minus
Sí.
15 seconds.
12 segundos. Se viene el despegue.
T minus 10, 9, 8,
7, 6, 5, 4, 3, 2, 1. Tenemos encendido y despegue de Falcon 9 desde el Centro Espacial Kennedy, marcando el inicio de la misión IMAP. Despega el Falcon 9 rumbo a 1,5 millones de kilómetros de nuestro planeta. Escucha ese audio.
And a beautiful solar transit. Well done to our Michael Caine for that shot.
Me encanta escuchar el audio de Falcon 9. Me encanta.
Everything progressing nominally with the Falcon 9 rocket as we're coming up on a minute into the count. The rocket is approaching max Q, the point of greatest aerodynamic pressure on the vehicle. It'll throttle back on its main engines as it's now passing the speed of sound. Coming up on max Q now.
Max Q.
Bueno, ahí continúa el ascenso de Falcon 9. Está superando el momento Max Q. Ahora en 5 minutos empezará el enfriamiento del motor de vacío Merlin 1D, el motor de la segunda etapa.
Coming up next will be the thermal conditioning of the Merlin vacuum engine.
And back chill.
Ahí tenemos en back chill. Todo continúa nominal. Me encantan las imágenes de la cámara de seguimiento. Me encanta.
T plus 2 minutes into flight, you can see all 9 Merlin engines. You
En
can
temas
see
2 minutos y medio
the
tendremos la
exhaust from
separación de
5 of them
etapas.
there. Beautiful shot looking back to the Earth. Got a couple quick call outs coming up.
Ya se viene apagado y la
Shut
separación.
off the engine at 2 minutes and 29 seconds. Stage SEP at 2:32, and then our first burn begins at 2:40. Here we go.
Stage
Ahí tenemos
separation.
apagado. Separación de ambas etapas.
And there it goes.
Y encendido de motor Merlin 1D optimizado para el vacío en la segunda etapa de Falcon 9.
On the left side of your screen, you can see the first stage booster falling away now. And on the right side, our second stage, flying IMAP, SWIFO L1, and Carruthers.
Mientras tanto, la primera etapa ya desplegó sus 4 rejillas de titanio y ya se dirige hacia la
First
barcaza
burn is a key
JRTI.
burn, Norman.
Correct. This is where we're trying to make sure that we're getting our
Y bueno, ahí pasamos ya a la transmisión oficial de SpaceX de que vamos a tener la separación de cofia.
Bearing separation confirmed.
Ahí tenemos separación de ambas mitades de la cofia a 112 kilómetros de altitud. Por tanto, la primera etapa se encuentra a 111 kilómetros y aumentando.
Now our 3 spacecraft, IMAP, SWIFT-01, and Carruthers are now exposed to the space environment. So one other note on these fairings, these are new fairings. The SpaceX, of course, is going to attempt to retrieve these fairings once they fall back to Earth. Just read the instructions. That beautiful drone ship that's sitting there in the Atlantic.
And we saw the fairings falling away. I think you can still see. Well, that might be some debris, but we got a good shot of them falling. And in fact, as you mentioned, they'll be recovering those. And the booster will be landing on the drone ship. The reason for the drone ship in today's mission is because we need all that performance.
La segunda etapa continúa encendido. Recordemos que debe llegar a 27.000 kilómetros por hora. Pero recién va a 10.000 kilómetros por hora y 50 kilómetros. Fíjense en el apogeo de la primera etapa: 132 kilómetros. O sea, fue bastante alto el apogeo hoy. 133 y sigue aumentando. O sea, el apogeo, no, yo me refiero a la altitud. Y por ahí se va a quedar. Ahí está, ahí empiezas a aumentar velocidad, 133 kilómetros de altitud. Llegó la primera etapa. Y ahora empieza a retornar hacia nuestro planeta.
Excuse me, once the first stage starts its boost back burn, drone ship's not burning anything.
Próximamente será en un minuto, será el encendido.
Inside your screen, we are burning that second stage. Go ahead, Amanda.
Yeah, just noticing here in the great views of that first stage, you may see some soot during the upcoming entry burn and prior to launch as well. So during the entry burn, that will be the second of 3 total burns. Falcon 9 will be decelerating by reigniting 3 of these Merlin engines on the first stage, and that will cause the vehicle to fly through Merlin's exhaust gases, or the rocket's plume. And that's what deposits the layer of soot on the vehicle's surface. It comes from the carbon-based fuel that Falcon 9 uses, and it builds up a little bit more on the outside of the vehicle, which really gives the Falcon first stage fleet the distinctive reused look. So we're looking out for that entry burn coming up shortly. The recovery and reuse of the first stage is what allows us to refly the most expensive parts of the launch vehicle, and that drives down the cost of going to space.
Ahí ya bajó desde los 100 kilómetros de altitud la primera etapa. Por lo tanto, la segunda etapa va llegando a 200 kilómetros de altitud. Ahora se vendrá el encendido de reentrada.
We're looking for that entry burn in just under 20 seconds from now. You'll be able to follow along with the Merlin engines relighting on the first stage. With the
ya nos debería cambiar el gráfico de motores. Ahí tenemos. Y ahí tenemos encendido de reentrada de la primera etapa. B1096, segunda reentrada que hace esta primera etapa.
That's the call for the first stage entry burn startup. We're going to be looking for entry shutdown here in a few seconds and finally looking at landing burn shortly thereafter. So stay tuned.
This is the second flight of this booster, and if all goes well, they'll bring it back down and fly it again.
Y reentrada completada.
Just 30 more seconds on that stage 2 burn.
El siguiente encendido será de aterrizaje del motor central, el motor número 9.
Our final destination.
Just about 50 minutes or so.
Stage 2 FTS is saved.
Por cierto, en caso de concretarse el aterrizaje, este será el número 134 sobre la barcaza JRTI. Ya baja de la velocidad del sonido. Apagado del motor de la segunda etapa. Se ve un aterrizaje de B1096. órbita de aparcamiento nominal
That's
de la
right, we're
segunda etapa
rapidly approaching the
a
landing burn.
189 kilómetros de altitud.
This landing burn scheduled to start in
Ahí
just
tenemos encendido de aterrizaje de la
It is
primera
starting up.
etapa. Ahí
This will
tenemos
last about
imágenes de
25
la
seconds,
barcaza.
and this will reduce the remaining speed of the vehicle for a soft touchdown on the drone ship. Just read the instructions. The booster is also equipped with 4 landing legs that will deploy for a vertical touchdown. So keep an eye
Ahí
out
tenemos
for that.
la barcaza ahí abajo.
Prior to landing.
Ahí tenemos vistas de la barcaza, despliegue de aterrizaje y tenemos aterrizaje confirmado de B-1096.
Beautiful touchdown there of the first stage.
Aterrizaje exitoso de la
Second
primera
landing for this
etapa.
booster.
Recordemos que este fue su segundo vuelo.
Must say that never gets old.
No doubt.
Y ahí tenemos en órbita ya a Falcon 9.
And now, the stack. There you can see it's not quite illuminated incredibly well, but up there is IMAP, Carruthers, and SWIFO L1. We will continue to monitor the progress during coast phase, but for now, let's send it back to the host desk with Megan and Kelly.
If you're just joining us, welcome to NASA's live launch coverage of 3 science missions. NASA's Interstellar Mapping and Acceleration Probe, or IMAP, NASA's Carruthers Geocorona Observatory, and the National Oceanic and Atmospheric Administration's Space Weather Follow-On Lagrange 1, or SWIFO L1. I'm NASA's Megan Cruz, and this is NASA heliophysicist Kelly Corrick, who is super excited to see launch today.
So excited to see launch today. It's always a great day to have a launch.
And with the beautiful sunrise.
Bueno, el próximo evento será el encendido del motor de la segunda etapa, que será en temas 1 hora y 12 minutos.
Yes, yeah, and the fact that you can feel it here, there is something special about actually being here and being able to feel that. And we're trying to tell you as much as we can about it, but there is something special about feeling the rumble and watching it go up and just knowing all those hopes and dreams and scientific discoveries are on their way now.
Yeah, it was really great to see you guys. Less than 10 minutes ago, again, a SpaceX Falcon 9 rocket lifted off from that launch pad right behind us here, 39A at Kennedy Space Center in Florida. It really was an incredible launch, and you really said it there. It is like we are watching the hopes and dreams of so many people from across the country that have worked together to bring these science missions to launch today.
Yes, yeah, and to protect our astronauts and to really understand that space weather that those 3 will study.
Right. Yeah, because all 3 spacecrafts are going to work together to study space weather. So, Kelly, what is space weather?
So, space weather is the effect of the sun on Earth and the entire solar system. That can range for things from creating satellite drag and shortening satellite life to affecting our GPS and affecting our power grids here on Earth. So it's really important to understand it so that we can mitigate those effects.
Yeah, a really wide-ranging swath of effects that we're talking about here. But doesn't NASA and NOAA already study space weather together? Like, what makes these 3 special?
Yeah, we do study space weather together, and this is the next generation. The SWIFO L1 is very dedicated and optimized to do the space weather that we know today that we need, not that we needed 20, 30 years ago. So that's very specified. And then the next 2 are the next generation of space weather. What are those things we're going to need when those astronauts are on the moon and Mars? We're learning that through the Carruthers and IMAP mission.
Gotcha. Kelly, thank you so much. Yeah, why don't we break down each one for our viewers right now? So IMAP is the primary mission of the 3. It will study the giant invisible shield surrounding the entire solar system called the heliosphere, which helps make life possible on Earth by protecting us from dangerous cosmic rays. IMAP will simultaneously study the sun's activity near Earth and also create the most detailed map ever of the heliosphere's boundary.
Yes, that great big boundary, that 9 billion miles away, is our first defense against the space weather that's created by the galaxy and those galactic cosmic rays that can cause some of that radiation sickness we were talking about earlier.
Gotcha. And then there's SWIFO L1, NOAA's newest satellite. It is the first NOAA satellite designed specifically for continuous 24/7 data collection of space weather. And as soon as it measures the strength and speed of incoming solar wind, it alerts NOAA. And this is usually 15 to 60 minutes before solar wind causes geomagnetic storms here on Earth. Those are crucial minutes.
Those are crucial minutes so that we can do those mitigation strategies from power grids to airlines to astronauts.
Yeah. And then there's Carruthers, the first ever dedicated satellite to continuously monitor the geocorona, or the part of the Earth's outermost layer of atmosphere. It actually glows. And this will offer unique insights into how space weather affects our planet. The mission is named after American scientist Dr. George Carruthers, who invented the camera that captured the first ever pictures of Earth's geocorona. Apollo 16 astronauts placed the camera on the moon back in 1972, and it's still there today.
It's still there today, and yes, and we're carrying on his legacy to really understand that part of our Earth's atmosphere that's so important in, again, mitigating those space weather effects.
Gotcha. Kelly, thank you so much. Our broadcast today will take us to around 9 a.m. Eastern Time, when the Falcon 9 second stage will deploy all 3 satellites into space. Let's welcome back Joy Ung now, who is with Casey Swales, NASA's Deputy Associate Administrator, and Nikki Fox, the Associate Administrator of NASA's Science Mission Directorate.
Casey and Nikki, thank you so much for joining me.
Thank you for having us.
How was launch for you guys?
It was amazing. I have to admit, I completely cried, and I'm trying not to do it again. Even the countdown, I got so emotional on this one. There's so much on there. There's so much heliophysics and so much great NASA science.
And our mom got to be on and got to see it. So it's
fantastic.
Amazing. Yeah, it's a beautiful day here at Kennedy.
Absolutely. So NASA is gearing to take astronauts back to the moon with the Artemis missions. Can you tell us how the 3 new missions today will help get us back to the moon, Casey?
Yeah, absolutely. So, you know, when we go back with Artemis, right, we're going further into space than we've gone in over 50 years. And when we send our astronauts, it's important that we're sending them safely. And in order to do that, we have to understand space weather. So even when you think about packing for a trip, what's the first thing that somebody asks you? What's the weather? What are you packing? And so we have to think about that. Understanding space weather, understanding the sun better, understanding solar flares, solar storms, radiation, how it impacts a spacecraft, how that spacecraft interacts with the crew. That's really important. So we're launching Artemis 2 next year. We're building a sustainable presence on the moon, and then we're going to send astronauts to Mars. And so when we land those astronauts on the moon, land them on Mars, it'll be missions like this that help contribute to making sure they got there safely.
That is very, very exciting. So Nikki, what other NASA science research is happening right now that will help inform the Artemis missions?
There's so much. I mean, every mission in our fleet is really playing its part in the Artemis missions. Science enables exploration, exploration enables science. And, you know, we are excited about all of the missions that we have up there. These are going to, you know, really give us cutting edge, the newest measurements. We've been measuring space weather for a long time, but these are just going to be this next generation. And then, of course, a little bit later this year, we'll be launching Escapade, which will go and study basically the weather and the space weather at Mars. And so we really, really are playing our part in the Artemis mission.
And so with astronauts going back to the moon, how will that benefit us here on Earth, Casey?
Yeah, so, you know, Artemis is more than just exploration, right? It's about inspiration. It's about national pride, national leadership. It's about economic growth. You know, for every dollar that's spent at NASA contributes to multiple dollars in economic output. It's about technology advancement, AI, robotics, advanced manufacturing, and that leadership that NASA does, you know, contributes across the world. And so that's really what Artemis is going to bring back to everyone here on Earth when we go.
Thank you so much for joining me, and I'm so glad that we could all be here for launch today.
It was a beautiful launch.
Yes, and thank you for having us.
Go IMAP.
Go IMAP.
Go others. Go SWIFO.
Go NASA.
Thank you, Falcon.
Okay, so back to you, Megan and Kelly.
Go, 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 go. That's right, guys. All right, we invited you to send in your questions about today's launch. So Kelly is ready for a few more, yeah?
Definitely, yeah. Love the curiosity. Keep them coming.
Yeah, really great questions so far. This one's from Zayshan Ahmed. How long does it take to build and integrate the satellites onto the rocket?
Yeah, these all took a long time. Satellites, 2017 was when this was initially proposed. And so then we took that time to actually build it up. Then you go through a design phase, then a build then you actually have to test it once you've built everything, and then you're integrated into the spacecraft. So it's taken the time from 2017 to now. So that's around 8 years.
Yeah, and that's IMAP specifically. And then in that process, we identified the rideshare SWIFO L1 and Carruthers, yeah?
Right, definitely, yeah. So within that, then Carruthers was a little bit shorter of a time frame in terms of 21. It was approximately the time when it was turned on and started actually building. But before that, folks have been designing these and thinking about them for quite a while. We always have that next question in mind, and that next generation, always innovating here. So it takes a little while to get those innovations into print and metal and then launched on a beautiful launch like today.
Yeah, that's what's so impressive about scientists, always thinking about the next challenge and how they could meet it. So, okay, well, again, thank you for sending us those questions. Just keep them coming using the hashtag AskNASA across our social media platforms. All right, so the IMAP spacecraft was built by Johns Hopkins Applied Physics Laboratory in Maryland. Here with us now is Dr. Martina Goulidou, a project scientist with APL. It is so great to have you here, Martina.
So happy to be here. I think my heart is still racing.
I know. How was it to see launch today?
Oh, it was amazing. I teared up a little bit.
No, I'm glad. Again, this is so important to you guys. Again, she's part of the IMAP team. Yes. So really, we've been talking about the science behind what we're trying to study here with these spacecraft, describing the heliosphere as a bubble, right?
Yes, exactly. You can think of the heliosphere as a bubble that is being inflated by the solar wind, a constant stream of charged particles that is being emitted by the sun. Mm-hmm. So maybe we can pretend this little guy is our sun?
Yes, so Martina had homework for me. She asked me to bring some props. So I have a balloon and I have a balloon pump. So you're saying the pump is going to be like the
sun. And the solar wind, so the strongest the solar wind, the more the heliosphere is being inflated. Mm-hmm. And now when the solar wind gets weak, our heliosphere is being deflated.
Okay, so the pressure inside affects the shape, the size.
Exactly.
Yeah, so what about the outside, though? What is that expanding into?
Yeah, so the whole heliosphere is actually flying through our galaxy and what we call our interstellar medium, gas and dust that is existing between the stars. When the pressure from that medium is strong, the heliosphere contracts even more.
Okay.
And when the pressure of that medium is weak, it allows the heliosphere to breathe again and expand. There we go.
Yeah. So basically, we are taking into account internal and exterior forces that changes the shape of the heliosphere. But why is that important to know?
Yes, so our heliosphere is actually a shield that protects us from harsh galactic radiation. So we don't know whether life would exist at Earth the way it is now if we didn't have that protective bubble, right? So it is important as we go and explore other exoplanets and other astrospheres, we want to understand first our home in the galaxy and how we came about.
And that's what IMAP's going to help us study.
Exactly. Go IMAP.
Oh, that's right. Go IMAP. Thank you so much, Martina. I appreciate you being here. And congratulations.
Thank you.
Okay, so IMAP is going to start collecting data about 3.5 months after launch. For more on that, let's bring back Joy, who's now with Dave McComas, IMAP's principal investigator from Princeton University.
Dave, thank you so much for joining me today. How was launch for you?
Oh, it was so exciting. We are all so happy. The whole IMAP team is just delighted.
So IMAP, as Megan said, is going to reach Lagrange Point 1, which is 1 million miles from Earth, around January. What do you expect IMAP to be doing and seeing as it takes measurements in January?
Yeah, so just incredible science. We'll be measuring the sun, what comes out from the sun, the particles, the magnetic fields. We'll be doing incredible space weather, helping our whole country understand what's happening that's coming towards us from the sun. And we'll be looking at the outer part of the heliosphere, the boundary of our solar system basically, and how that interfaces with the galactic medium around us.
As you just mentioned, IMAP is going to be studying the edge of the solar system, the heliosphere, as well as real-time solar activity coming off of the surface of the sun. Why was it important to build a mission that could do both of those things?
So we've worked at both of those pieces before with other missions, but they've been on different spacecraft. They haven't been intercalibrated. They haven't been able to do the holistic science. Putting it all together on one spacecraft allows us to do the complete integrated science and understand our neighborhood of the sun.
And so as the principal investigator of IMAP, what are you most excited for discovering with the mission?
What I'm most excited about is the things I don't know about. I know we're going to do a lot of great science, all the stuff we promised in our proposal, great new measurements, great new understanding. But the really exciting thing is when you fly new instruments that are much better than older instruments, you discover new things that you can't even imagine when you launch the spacecraft. That's really exciting.
And how do you anticipate IMAP to be working with all the other heliophysics missions that NASA has?
Yeah, I think IMAP will be sort of a cornerstone for all of the heliospheric missions. There's a lot of great science that can be done by comparing data from different missions and different positions, and we hope to be sort of in the lead of doing that work.
Well, thank you so much for joining me, and I'm so thrilled that IMAP launched today.
We are too. Thank you so much.
Okay, and so let's head back to Megan and Kelly.
Managing today's launch is NASA's Launch Services Program based here at Kennedy Space Center. It essentially acts as a broker to match uncrewed spacecraft like the 3 today with suitable rockets for launch. NASA's Daryl Nail spoke to a flight and structural loads analyst about the challenges of getting 3 spacecraft safely into orbit.
And we are here with Natalie Hintz, who actually did the structural loads analysis for the IMAP mission. Thank you for being here.
Yeah, thank you for having me.
So structural loads sounds complicated, but explain why it's important for us to know what's going on inside that rocket with regards to all the structures.
So we have this spacecraft which has all of these delicate instruments and components that have been designed with their science in mind. However, they're not really that structurally strong, and we are taking these spacecraft, we're putting them on top of a launch vehicle, in this case a Falcon 9, which has all of these rocket engines that are going to blast it from the surface of the Earth into orbit, and it's going to endure a very violent launch environment.
It's a lot of shake, rattle, and roll happening inside of a rocket.
Absolutely. So when it comes to a spacecraft in a launch vehicle system, it's going to be much more complex. Imagine that the central beam is a launch vehicle, in this case a Falcon 9, and we have a mass at the top which is representing a spacecraft, in this case IMAP. Look at how that system is being excited. I'm not shaking the base very much here, and yet look at how much it is actually vibrating. I'm activating the first mode of this system.
We think of this as, something that's not good inside of a rocket if it were to move around like that in that clamshell.
We actually have a system of spacecraft. So we have IMAP, and we also have its ride shares, SWIFO L1 and Carruthers, which are hanging out on an ESPA ring just underneath IMAP.
That's right.
So I actually brought my own SWIFO L1 and Carruthers here so that we can understand how that's going to change the system.
These are wood blocks, but they got weight on them, and so they essentially kind of, they're a good analog for what you're doing, right?
Exactly. So we can attach them here to this rideshare ring, and that is going to simulate the addition of the mass and overall structure of those rideshare spacecraft. All right, so you can already see here the static deflection is changing because we've added mass to the system. But not only that, we're not really interested in the static shape here. We are interested in the dynamic shape. So again, it's sitting on the pad, getting ready for liftoff. The engines ignite, and look at how much more it is moving. Not only that, but the shape that it's moving at has changed. So looking at the spacecraft here, we have IMAP on top of a payload adapter and a rideshare ring, which has SWIFO opposed to Carruthers. And all 3 of these spacecraft are forming one unique payload stack, one unique system. Throughout our coupled loads analyses, we derived the launch environment that these would experience during flight. And much like I shook this rocket model, we also shook those spacecraft during vibration testing to make sure that they are rated to and can survive the vibrations that these spacecraft will see during launch. So in the end, we found that through analysis and testing, these 3 spacecraft are ready to go, and they are good for launch.
Thank you so much, Natalie. Appreciate the time, and thanks for explaining it.
Absolutely.
Now, this isn't the first time NASA and SpaceX are working together to send great science into orbit. For more on that, let's head back to Amanda and Hawthorne.
Thanks, Megan. Since 2016, NASA's Launch Services Program has partnered with SpaceX to fly some of the agency's most important science missions, spanning everything from Earth climate monitoring to astrophysics and planetary defense. In 2016, we launched our first LSP mission, JASON-3, which was a payload to measure global sea level rise. That success paved the way for TESS in 2018, a mission that transformed our search for planets by scanning nearly the entire sky for new worlds. In 2020, Sentinel-6 Michael Freilich carried a radar altimetry reference mission to extend the legacy of sea surface height measurements. This is critical to understanding climate change. Altimetry is the study of height, or measuring altitude, things that go up. And in this context, Sentinel-6 carries a suite of instruments which provide high accuracy altimetry data monitoring for sea surface height, significant wave height, and wind speed, as well as monitoring inland water levels and ice characteristics. Then in 2021, LSP entrusted Falcon 9 with DART, the first ever test of planetary defense. And that went on to prove that humanity could intentionally change the orbit of an asteroid moonlet. That same year, IXP opened a brand new window to the universe by measuring the polarization of X-rays from black holes and neutron stars. The collaboration continued with SWOT in 2022, which is now delivering detailed global maps of rivers, lakes, and ocean currents. And then with Psyche in 2023, a Discovery-class mission to explore the metal-rich asteroid 16 Psyche. This will reveal how planets may have formed, and that launched on Falcon Heavy. PACE, GOES-U, and Europa Clipper all launched in 2024. Europa Clipper, NASA's flagship mission to Jupiter's moon Europa, was sent to search for signs of life beneath its icy shell. PACE and GOES-U are working to advance our understanding of plankton, aerosols, clouds, and ecosystems that regulate Earth's climate to strengthen severe storm and space weather monitoring, respectively. In March of this year, Falcon 9 launched the SphereX mission to survey the entire sky with infrared light. That launched alongside Punch, which will study the sun's outer atmosphere. Just in July, tracers delivered twin satellites to investigate magnetic reconnection, the fundamental driver of space weather. That brings us to today, where IMAP will head out to chart the boundary where solar wind meets interstellar space. And later this year, Sentinel-6B will take the next step in precision ocean altimetry, extending the global sea level record, which is critical for tracking climate change. Now, looking ahead, the Nancy Grace Roman Telescope, an observatory designed to study dark energy and dark matter, search for exoplanets and image them, and more, will tackle some of the biggest questions in science while generating data to help protect the Earth. In less than a decade, SpaceX has built a proven track record with NASA's Launch Services program, establishing Falcon as a dependable launch platform for some of the most ambitious and groundbreaking science of our time. And that brings us back to today's IMAP mission, where we are just under an hour from the beginning of spacecraft deployment. So let's check back in with Megan.
Yeah, it's time for more questions from social media. The first one is, what new technology is being used on these missions?
That's a great question. So a lot of these missions have developed new technology in terms of the cameras that they use, in terms of like the camera in Carruthers. Although Dr. George Carruthers built an amazing thing, there's been a couple of advancements since 1972.
I would hope so, yes.
Yes, I hope so. So there's been some updates there. All of the detectors have been updated, and all the new instruments on IMAP are improvements upon the older versions of these. And for SWIFO L1, since it's operational, it is an upgraded version of former instruments, but it's not too far off, because again, we want to make sure that they're the same, we have a consistency in those measurements and that they're very similar to past measurements.
Yeah, absolutely. That makes sense. You want to make sure you're still, even though there's advancements like comparing apples to apples, essentially.
Yeah, you want to keep that the same.
Got it. Same fruit. Now, this next question is Chili Maple. How long will mapping the heliosphere take, and when will the research contribute to safeguarding Earth?
Oh, that's a great question.
Yeah.
So to actually map the heliosphere, it's going to take a while, because the spacecraft takes turns and basically gets little bits of the sky every time it turns. And to make that full rotation as it rotates with the Earth, it takes about a full year to get one of those maps. So that's great, because we have a 2-year mission. However, it also has the iAlert system on IMAP, which will be able to feed us data basically instantaneously, or within 30 minutes, get data about space weather that will be beamed back. So that long-term space weather, that galactic space weather, will take about that year, but that instantaneous will get started in 6 months once it's fully commissioned.
Wow, very impressive. Thank you so much, Kelly. Yeah. And as Kelly said, really, really great questions. Yeah, keep them coming. You still have time. Again, using that hashtag AskNASA on our social media platforms. Now, all three spacecrafts, IMAPs, Carruthers, and SWIFO L1 will monitor space weather from Lagrange Point 1. That's about 1 million miles away from Earth towards the sun, and specifically, as you can see in that graphic, they're specifically on the line connecting the two. Why specifically here, Kelly?
Specifically there at the L1 point is the balance between the gravitational pull back to Earth and the gravitational pull towards the sun that allows them to have that use relatively little fuel and stay there for a while. It also gives them the direct view. If you're around Earth, sometimes Earth gets in the way of the sun view, sometimes the moon gets in the way, and so you don't have those continuous viewing angles. So you really want to be on that line to save fuel and to have the direct view to the sun and to be in front of the Earth so that we have those 30 to 60 minute warnings.
Yeah, and again, I love that this is a ride-share mission. You know, we identified 3 that were going to want to go there anyway. They might as well fly together.
Right, definitely. It's again, the cosmic carpool is the best way to put it. It was the trains going in one direction, everybody get on, let's stop there.
That's amazing. Now, all 3 satellites will continue the important work of space weather satellites already at Lagrange Point 1, but that have been operating well beyond their intended lifespans. We were kind of talking about that a little bit ago because of one of the social questions. You know, SOHO launched in 1995 and was only supposed to run for 3 years, but it continues to collect data. Then ACE launched in 1997 and, like SOHO, far exceeding its 5-year lifespan. And then there's Discover, which was also designed to operate for 5 years, and yet that launched 10 years ago, Kelly.
Yes, all of these spacecraft have been doing an amazing job at understanding our space weather and started as really more science-driven, that inquiry. And so we learned so much about space weather from the 1990s to now. And so we need really that upgrade, that next generation. What really works for us? What do we really need to know? Maybe a quicker cadence or a little less cadence to really get the information down to protect everything from our astronauts to our pilots and our farmers.
Yeah, and what I find really impressive again is NASA and NOAA have been monitoring and studying space weather together for more than 50 years. So let's go back to Joy, actually. Now she's with Paul DeBar, Deputy Secretary of Commerce.
Paul, thank you so much for joining me.
Oh, it's great to be here. Great to be back again for another launch.
How was that spectacular launch for you?
Oh, I mean, it was perfect. I mean, what a beautiful day, and most importantly, all the scientists and engineers who've been working on all 3 missions for a very long period of time. This is a culmination of a lot of science and effort.
Absolutely. So can you tell me, how do NASA and NOAA work together when looking at space weather?
So overall with space, NOAA has a giant set of constellations of satellites looking at all sorts of different weather in LEO and GEO, and obviously dealing with hurricanes. But when it comes to space weather, obviously it's a much bigger, newer issue with technology in space and telecommunications and 5G and then 6G coming up and GPS. For us to be able to move from science of taking a look at heliophysics to being able to see what it could affect our technology and be able to react to that is very, very important, and that's what this mission's about.
And how has studying space weather for the past 50 years benefited us here on Earth?
So the basic discovery of heliophysics, which some of the other missions, IMAP in particular, is doing right now, has laid the groundwork for us to understand the various heliophysics issues and magnetic storms, coming off of the sun, and has allowed us to be able to build a sensing device for what's called applied applications, right? For applied issues, and that's what our satellite is. That's on this package here today.
Have there been any memorable predictions that have helped mitigate the effects of space weather on Earth?
Yes, so in May 2024, so not that long ago, there was about a 3-day storm period in the sun. And we had existing assets to be able to map that. And we were able to support giving notifications just like we do with hurricanes at NOAA, but for, in this case, a space storm, coming from the sun. And we were able to help various different technologies and users to take precautions. It still caused impact on Earth, and so that's why having a next generation and our efforts in Boulder for our Space Weather Center of communicating this data that we will be getting to a broader number of people around the world will be able to help move that forward and prevent issues from solar storms.
Yes, it's definitely a very exciting time for forecast and for science. So thank you, Paul, so much for joining me.
Thank you.
And I'm so glad that we had a wonderful launch together.
Thank you very much.
Okay, so let's head back to Megan and Kelly.
Thank you both. All right, it's been about 40 minutes since launch here at Kennedy Space Center. Let's check back in on IMAP, SWIFO L1, and Carruthers with Daryl and Norman.
All right, we're coasting and doing a good job of coasting as we continue to climb into this trajectory. We are going higher and higher and higher. This is a very highly elliptical orbit that we're going into, much different than just your circularized orbit for low Earth. We got to get out to 1 million miles, so we're really getting high in this orbit.
Yeah, correct. So for us to go to L1, it's almost as if we have to do an escape trajectory, although not quite. Our C3 is still kind of negative, so we're not quite on
our C3.
Our C3. Yeah, it's the energy it takes for us to actually leave Earth's gravity, right? So it's not quite positive, which means we would need that to actually be, to actually leave Earth's gravity field. But we're close, right? So we need that highly elliptical orbit for us to actually achieve that. The other thing I'll mention too is that, you say we're coasting. People are like, oh, you're not doing any work right now. Well, that's not true. We're actually right now doing a very optimized flight right now. We're trying to make sure that we fire our second stage at just the right time so that we can transfer from our trajectory or our altitude we're at now to the higher trajectory that will push us at the point where we actually can separate our spacecraft so then our spacecraft can go to where it needs to go to do its science.
For the record, I'm still working, and you are too.
Still working, yeah.
Yeah, still working. But coasting, and thank you for pointing that out. We also will be sun-facing.
Correct.
And that's important at the time of release.
Correct. So the idea there for sun-facing was that we wanted the sun right to be on the solar panels for IMAP, and that's for a couple of reasons. As you have heard before, IMAP's on internal power, right? So for us to get back some of that juice into our batteries, we want to be sun-facing so all that sun's energy can get back into our batteries, right? Solar panels produce energy, which is always a great thing for our spacecraft. We like that. Yeah. The other thing there, too, is that by actually using the solar panels on IMAP, we actually are using it almost as a solar shield, right? So it's reducing the thermal strain on the instrument suite of IMAP and the instruments on both Carruthers and SWIFO L1. So they're actually doing double duty there. So we want to thank IMAP for their service to the cause here.
Absolutely. And in fact, because of that shading, Carruthers needed their own warmth, right? Some heaters in order to keep them warm because they can't see the sun at the moment.
Correct. And there was a fear at some point that given that Carruthers was not on, that the hydrazine lines that they had, the rocket fuel would possibly freeze. Freezing lines is bad.
Especially when it's your fuel, yeah.
Exactly. So we want that to be liquid coming out. So we want to make sure we had heaters on those lines provided by SpaceX to actually make sure that did not happen.
All right. Well, the next time you see us, we'll be getting ready to do a second burn of that second stage, which will be key to get it into and set it up for the separation of all three spacecraft. So we hope that you'll join us then. That's in about T+1 hour and 12 minutes. So just a little over a half hour. In the meantime, we'll send it back to Megan and Kelly.
Yes, Megan and Kelly both here, and
and in it for the long haul.
And in it for the long haul because, yes, as they just said, the second stage is going to coast now for about another half hour. So it's time for this team to take a little break. But again, we will be back 8:40 a.m. Eastern time to continue with live coverage of IMAP's, SWIFO L1's, and Carruthers' journey to Lagrange Point 1.
Yep, join us for that separation.
Exactly. 8:40, set an alarm. See you then. I'm NASA's Megan Cruz, and this is NASA heliophysicist Kelly Corrick.
Hi, everyone.
We are back from a short break to continue live coverage of 3 new space weather missions that are headed about 1 million miles from Earth. NASA's Interstellar Mapping and Acceleration Probe, or IMAP, NASA's Carruthers Geocorona Observatory, and the National Oceanic and Atmospheric Administration's Space Weather Follow-on Lagrange 1, or we like to lovingly shortly call it
SWIFO L1.
Now, liftoff was a little more than an hour ago at 7:30 a.m. Eastern Time. If you missed it, check it out now.
6, 5, 4, 3, 2, 1. Engines full power. And liftoff. Go Falcon, go IMAP, go SWIFO L1, and go Carruthers.
Ahora sí, retornamos a la
Now, Kelly, you were very excited during launch. I remember you going...
3 new missions.
Yeah, there was just so much excitement there watching that go off, and it's such a beautiful rocket. And then when you start to actually feel it...
Se viene el segundo encendido, lleva 1 hora con 12 minutos y 28 segundos.
Yeah, and so what's next for our journey? Let's bring back our team of launch commentators, NASA's Daryl Nail and Norman Phelps here in Florida, and Amanda Years from SpaceX, joining from Hawthorne, California.
All right, thank you very much, Megan and Kelly. And we are here again inside Hangar AE, where we've got all the mission managers who have gotten together to watch some really big moments. And one of them is the second burn, which is coming up at T plus 1 hour, 12 minutes, and 28 seconds. So we got about 2.5 minutes before we get to that, about 1.5 minutes. You know, as we get ready for this burn, it's important to note that we are not going to be able to see this burn, and there's a reason why. We're going to be on the TDRS network, not the SpaceX ground station network. Can you explain what's going on there?
Yeah, correct. This is actually just a planned outage, right? We always knew that we would not have ground station coverage for this portion of the flight. But, I mean, this is what we do, right? We plan these things out. We make sure that we have telemetry that we can store and forward that telemetry so we can look at it later. So this was always planned, so no issues here. But.
And in fact, TDRS, they'll be able to get data in real time, right, as that's coming. So they can see the data. We just won't be able to see the video.
Correct. No video, but we will be able to get the data, exactly.
Get the data, get the video later,
Get the video later, you're right. And then
store
you get the
that.
data. Yep.
The other thing that's kind of interesting about this burn, I mean, it's a short burn. It's 1 minute and roughly, a couple seconds or so. But, boy, this thing gets up and goes in that short period of time.
Yeah, this is a very, very important burn, as I mentioned earlier. This is the burn where we're taking it from this lower altitude to a higher altitude, kind of taking it out of that circular orbit to a highly elliptical orbit where we will then go to our L1 Lagrange point there in space. So very, very important burn.
Y bueno, ahí se aproxima ya el segundo encendido. Ahí se nos carga el indicador pasaje. Según el timeline debería ocurrir justo ahora. Y a ver si nos muestran imágenes. Por cierto, miren el fondo, las imágenes del lanzamiento de Falcon 9. Miren la pantalla grande. Wow. Excelente imagen. A ver, andamos aguardando el encendido. El segundo encendido del motor Merlin 1D optimizado para el vacío en la segunda etapa. Ahí tenemos encendido confirmado. 4.5G, 4.6, 4.7, 4.8 y aumentando.
Yeah, that's right. So the second stage again, single Merlin vacuum engine.
Parece que no tenemos señal suficiente para tener las cámaras.
A minute long here. You may have also noticed that MVAC engine is equipped with a wider and taller nozzle compared to the M1D engines.
Y dice el apagado en 10 segundos aproximadamente. Bueno, un poquitito más porque
Although we can't see it, we do have that telemetry there on your screen of the engine firing.
5.8.
Last burn prior to payload deployments and just a few minutes after.
Y ahí vamos a tener el apagado ahora. Para en unos segundos.
We should have shutdown shortly of the MVAC engine. This is generating around 220,500 pounds of thrust in vacuum.
Y ahí tenemos el apagado.
So the first stage, those M1D engines each achieve around
38.000 kilómetros por hora.
MVAC shutdown during ascent and descent, and then we have the on-time shutdown of the MVAC engine. So with that, the second stage will continue to coast for just about 10 minutes, and then we'll begin the payload deployments. In the meantime, let's check back in with Megan and Kelly.
Thank you, Daryl, Norman, and Amanda. And as we await those separation events, Kelly, what is space weather and why is it so important to have IMAP, SWIFO L1, and Carruthers studying
Por
it?
cierto, la altitud no está cambiando. Está en 181.
And it really affects our technology. It can bring beautiful things like the aurora, but it could also affect things like precision agriculture, our GPS, our aviation, not flying over the poles, as well as our astronauts are in danger sometimes when those energetic particles are coming towards them.
Yeah, so let's learn about each spacecraft.
Aunque bueno, 1 hora 15 desde el lanzamiento. El próximo evento ya será el deploy. De que voy a mostrar el timeline. Que el deploy será en temas 1 hora con 23 minutos y 51 segundos. El deploy de IMAP. Después tenemos temas 1 hora y 30 y temas 1 hora y 36 minutos. Las otras 2 cargas útiles que se separarán de la segunda etapa de Falcon 9.
The boundary of the heliosphere, located around 11 billion miles from Earth at its closest point, is hard to study. But that's changing with IMAP. As a modern-day celestial cartographer, IMAP will
Ahí se actualizó la
of the heliosphere and help us understand fundamental processes happening across our solar system.
Estaba fallando la telemetría de la altitud. Ahí están comentando los puntos de la range. Recuerden que el SimWeb está en L2 a 1,5 millones de kilómetros, pero vendrá a ser hacia el lado del Sol, no, hacia el otro lado. O sea, para que se entienda. Superamos, o bueno, no, ahí superamos los 300 kilómetros de altitud, como va subiendo rápidamente la velocidad, la altitud.
IMAP's measurements will give scientists a more complete look at our heliosphere than
Ahora vamos a tener la separación de las cargas útiles en aproximadamente 6 minutos.
solar particles and radiation that are headed toward Earth. This information will be essential for the future of human exploration as astronauts venture to the Moon, Mars, and beyond.
NASA and NOAA have been monitoring the sun and its effects through space for more than 50 years. SWIFO L1 will be NOAA's first ever satellite dedicated to monitoring space weather 24/7.
Meet SWIFO L1, NOAA's first purpose-built space weather observatory. When a solar storm erupts from the sun, SWIFO L1's coronagraph observes the event right away.
Por cierto, recordemos que la primera etapa lo logró estar con éxito sobre la barcaza JRTI. Por cierto, Starship in Pink nos pone: hola, buenos días, esperando el despliegue. Bienvenida al directo. Sí, andamos esperando el despliegue de los satélites. Bueno, recordemos de que va una sonda, un satélite meteorológico, por decirlo así, y un telescopio espacial.
Spacecraft spots a storm with its coronagraph. It watches the approaching weather and waits. Somewhere between 18 and 70 hours later, the incoming storm passes over SWIFO L1. Then, the spacecraft's instrument suite measures the storm's severity and speed and sends that data home too, giving NOAA early warning somewhere between 50 and 60 minutes before the storm arrives at Earth. NOAA's Space Weather Prediction Center in Colorado is constantly on the alert, using all the data SWIFO L1 collects to develop and communicate real-time forecasts and warnings to industry, government agencies, and the public, so they can take action before the storm arrives to minimize its impact.
And the other secondary payload hitching a ride with IMAP is NASA's Carruthers. It will give us unique insights into how space weather affects our planet by monitoring Earth's exosphere.
The goals of the Carruthers Geocorona Observatory are to study the nature and origin of Earth's exosphere and how it evolves over time.
The exosphere itself is the uppermost layer of the Earth's atmosphere. It's comprised almost entirely of atomic hydrogen. This is the lightest chemical species in existence, and it floats away, essentially evaporates off of the top of the atmosphere. And when the sun shines on these atoms, they essentially scatter it off into all directions, and so it glows like a gigantic halo around the Earth. And so that's called the geocorona, that fuzzy halo of light that's given off by those exospheric atoms.
Many times we think of the transition between the atmosphere and space as being this very abrupt boundary where at one altitude you've got atmosphere and the next altitude you have space. But in reality, this transition is much more gradual and can extend over thousands of kilometers. By imaging the geocorona, we can actually answer fundamental questions about the size of the exosphere, the structure of the exosphere, and how it changes over time. And all of this in response to the input from the sun.
And we asked you guys earlier in the broadcast to send us your questions using hashtag AskNASA. Thank you so much for sending those in. Let's answer one now. This is from Kevin Shannon asking, L1 sounds like a crowded place. How will the observatories stop from blocking each other's measurements?
That's a great question, and it does sound like there's a lot there, yet at the same time, space is very big. It's nowhere near as crowded as low Earth orbit because it's actually kind of difficult to get that, to make that million-mile trip. So what they do is they have very wide orbits, like 60 to 100,000 kilometers. So this is not, they're very spread out, and they have all coordinated and make sure that they don't block each other.
Okay, perfect. Thank you so much again. L1 Lagrange point 1, the location for all these 3 satellites for them to do their science. All right, so we promised you our broadcast today would take you all the way through all 3 satellites deploying into space. We are now just minutes away from those events happening live. So let's bring back in launch commentators Daryl Norman, and Amanda.
That's right, and we are here, and we are looking forward to this big moment, the separation of the first of 3 spacecraft on board this second stage for the Falcon, and that is the IMAP spacecraft, SWIFO L1, and Carruthers. And they're going to go in that order, and there's a reason why.
Yeah, so first of all, I just want to say, too, that until we get to spacecraft separation, until we get to AOS, also known as acquisition of signal, our mission is not really successful.
Miren de fondo el tanque de flotante de
But
la
yeah, so
segunda
IMAP actually is the primary here. So IMAP gets
La
first
pantallita
dibs
de
on
fondo,
its
el
separation.
tanque
It
de
has to make sure
propelente
that
de la
there's
segunda
enough
etapa.
commodities, there's enough onboard things for IMAP to actually meet its requirements. So IMAP gets first dibs here on this first separation here.
And we're looking for that in just about
No sé
a
qué son
minute.
los
And
parpadeos
it
eso
should be
de luz que se
interesting to
veía.
see because
Qué bueno.
before it separates, the second stage is planned to spin up to 4 RPM, 4 revolutions per minute. And it's very important for IMAP to be spun up by the second stage.
Correct, but even before they spins up to that 24 degrees per second or 4 revolutions per minute, the launch vehicle is actually going to slew towards the Earth a bit too before it gets to do that. And that's another challenge for this mission, is that each of the different ride shares both had different orientations that actually to be deployed at. So you not only had to account for all the other requirements, you also had to account for which way they wanted to be pointed when they actually were separated. But to answer your question, yes, so the first thing to happen is going to slew to the IMAP attitude. We're going to spin up that second stage up to 4 RPM, right? And then we're going to deploy IMAP. And then after we deploy IMAP, the launch vehicle then is going to arrest at 4 RPM. And then it's going to slew into the SWIFO L1 deploy attitude, and then deploy SWIFO L1.
Bueno, se viene el deploy
It's going to slew a
de
different
IMAP.
direction to the Carruthers preferred rotation, and then deploy Carruthers. So that's our sequence there.
A very delicate dance indeed, and so we want to hopefully have a picture of this. It would certainly be nice. We're not guaranteed. We do need to remember, based where we are in track. Oh, there we do. We do have a camera. That is the backside, so that's good. Hoping to have a live view of IMAP separating off the top of the rocket. We'll have to
kilómetros
wait to
de
see if we're
altura.
able to pull in that signal.
Yeah, that's going to be a spectacular image when we get that image.
Y ahí vamos a tener, según el timeline, el despliegue de IMAP en 5 segundos.
One thing I will mention too is someone may ask the question, why does IMAP need to be spin stabilized, right? And there's a couple reasons for that. Number one, right, we all know from physics, right, that if you ask something that's spin stabilized, it doesn't perturb. So you can see it there in the image right there. IMAP is spinning
There we
up,
go.
which
That's
is
that
Esa
4
rotación es
revolutions per minute
normal.
we were talking about. That is not something that is wrong.
¿Es normal
That is
esa
intentional.
rotación?
You're looking forward. Any moment now, we could have separation of the IMAP spacecraft.
Espero que sea normal.
IMAP deploy confirmed.
Bueno,
So there we
deploy
go.
de IMAP.
IMAP has separated, beginning its mission to map to the solar frontier and reveal how the
Esa
sun
rotación
shapes
es
our space
normal.
environment.
Me preocupa.
Go IMAP.
You spin me right round, baby, right round. Like a record, baby, right round.
Yeah, there you go.
That's a great view.
It is. It's a great view. But the primary reason we do need a spin stabilized, though, too, besides the angular momentum reasons, right, is it gives us
Vale. Ahí está controlado
full
ya.
360-degree view of the medium that it's trying to study. So very, very important there.
Now, the second stage has already arrested that spin or stopped the spin.
Correct.
Because the other two
Vale,
spacecraft
aparentemente era normal.
IMAP is on its way
Es raro,
with
pero
this ever-important spin. Now
bueno.
we've got another couple of big milestones happening.
Bueno, se separó la sonda IMAP, vendrá a ser la principal de esta misión, la que le dio el nombre a esta misión.
A big celebration. This will be the IMAP Mission Operations Center at
Posteriormente se vendrá
Applied Physics
la
Lab.
separación de la satélite de la NOAA.
Is looking now for the acquisition of signal, and
Y por último, la separación de Grade. Por cierto, ahí estamos esperando. A ver si. Uy, me saltó la pantalla de inicio de sesión. Pero ahí teníamos. A ver si. Vaya a tener la señal.
That AOS pretty
La
quickly.
frecuencia, ¿no? No sé, a ver. Aunque bueno. A ver si pronto obtienen señal de IMAP y se empieza a comunicar con Tierra. Si no, ahí sí que tenemos un problema.
IMAP is currently running an autonomous sequence, so it's spring-loaded. As soon as it came off the spacecraft, it started running an operation.
Correct, yeah. So they have all these commands already preloaded in there. And so they're going through now probably their health checks, autonomous health checks, and also trying to
Miren ahí al fondo IMAP tapando el sol con cómo está girando. O sea, espero que esa rotación haya sido normal. De que aparentemente sí fue normal porque enseguida, después de la separación, la frenaron. O sea, pero me sorprende de que haya sido una rotación fuerte. Que por cierto, tenemos señal de IMAP. Si no veo mal, tenemos señal de IMAP. A ver si la ponen en grande esa pantallita. O me acerco yo a la pantalla.
Yeah, we just received
Sí,
word.
aparentemente hay señal.
So go IMAP. That's excellent news.
And that came fast because they had that lock on Hawaii. They also have 2 ground stations from the Deep Space Network in California. So they locked in acquisition of signal. That tells them that IMAP so far is there right where they expected.
Exactly. They knew where to look in the sky, and they were primed and ready to actually talk to the spacecraft when it was ready. So kudos to them. I love physics. I love when things work the way they're supposed to work. This is great
and
stuff.
It's a beautiful thing to watch it live as well.
It's a beautiful thing to watch it as well. Agreed.
So our next major milestone would be the separation of SWIFO L1, which is still on the stack. That's scheduled for T plus 1 hour and 30 minutes. So we're just about a couple of minutes away from that one.
Correct. And as you commented before, we already arrested the spin rate because SWIFO L1 does not need to be spin stabilized. So that's good news as well.
Fue sobre un susto, pero, o sea, fue controlado, fue totalmente nominal esa rotación. Por cierto, este destello que se ve son las líneas de RCS de la segunda etapa.
Yes, absolutely. We have had some outstanding views this morning. Congratulations to the IMAP team on that successful deployment.
3.000 kilómetros de altura ya. Recordemos que el punto L1 se encuentra aproximadamente a 1,5 millones de kilómetros de
looking ahead, we do have 2 more deployments. Next will be SWIFO L1, and that will be followed shortly by Carruthers. As a reminder, SWIFO L1 is the National Oceanic and Atmospheric Administration satellite, and that will be monitoring space weather 24/7. It will essentially act as an early warning beacon for potentially disruptive space weather events, and that's critical because those could impact both communications for astronauts in orbit and also us here on Earth. We're expecting the next deployment in just over a minute from now. You saw during that IMAP deployment that we required a spin of 24 degrees per second. And that's actually the fastest spin deploy that we've supported on Falcon 9 to date. Of course, that's not required for the following 2 rideshare payloads. You see some great views of stage 2 as well. Now, if you are just joining us, we did have an on-time liftoff this morning at 7:30 a.m. Eastern Time from Cape Canaveral Space Force Station. During that flight, we achieved successful stage separation and re-landing of the first stage booster, completed
Y ahora
2
vamos a
burns
tener
on the
la
second
separación del
stage to get
satélite
to this point,
meteorológico según el timeline.
and we've deployed the
Por cierto, en
first
el
of 3
timeline
payloads. That's
de
IMAP
SpaceX
has already
no nos
been
muestra,
successfully deployed. SWIFO L1
pero
and Carruthers
debería
as well.
ocurrir justo ahora.
Now, for the Carruthers payload, this is equipped with a geocoronal imager, and this will be able to detect fundamental characteristics of the outermost layer of Earth's atmosphere. We're listening in
Aquí tenemos el
for the
deploy.
deployment of SWIFO L1.
Ahí tenemos el deploy confirmado.
Deploy confirmed.
Beautiful separation and successful deployment of the SWIFO L1 payload. We're not done yet. We do have one more payload coming up. That's NASA's Carruthers Geocorona Observatory. We already received that acquisition of signal from the IMAP payload.
So Carruthers.
Now, AOS, as a reminder, this is a AOS, we already had that for IMAP, and that's a critical milestone for these payloads. It's the first communication from the payload to the ground stations on Earth, and it's normal for a spacecraft to take a few minutes to complete a startup and commissioning sequence, but acquiring that spacecraft signal here on Earth is like having our outgoing call answered. And it helps us to confirm the system status and health, so it's great news that we already received that for IMAP, and the AOS for the remaining payloads will come at a later time. So right now we are just awaiting the deployment of Carruthers.
That's right. We want to let the audience know if you want to catch up on the AOS for SWIFO L1. We've got a code that you can scan with your phone on your screen, and you can find out when they get the acquisition of signal. Again, that's the acquisition of signal for NASA and NOAA's SWIFO L1. In the meantime, we're coming up on Carruthers separation. That one scheduled to happen in just about 3.5 minutes at T plus 1 hour and 36 minutes. There is a shot of Carruthers, the last but not the least of our spacecraft. And now Carruthers is helped by having IMAP off the stack because they get some sunlight on them, which it's important for them to have some heating.
Correct, yeah, it does reduce some of the strain. Strain is probably the wrong word, but it does reduce the need as much for those launch vehicle heaters, which are keeping their lines open at this point. So the sun is a good thing.
It is, especially when they're hydrazine lines. You want to keep those warm because that's your fuel.
Yeah, we want hydrazine to stay fluid. We don't want it to turn solid on us. So solid hydrazine, bad.
Again, if you want to track SWIFO L1's progress towards acquisition of signal, we got a QR code for you to scan. And there you see it. Just grab that image and you can track NOAA as they seek to acquire the signal for SWIFO L1. Back to Carruthers now. Just a couple minutes away from separation off the second stage, the third spacecraft to separate. So far, great separations for the first two, IMAP and SWIFO-L1, looking to have another good one for Carruthers. Carruthers, different in that it was not powered up before launch. It is going to power up after it comes off the rocket.
Correct, and that was always planned for this mission. So the team there at Berkeley, which is going to be taking control of the satellite after separation, they've already practiced this procedure. They already have everything down to the T, how they're going to turn the spacecraft on, perform all the health checks to make sure that
Y bueno,
everything is
superamos los 5.000 kilómetros de
in
alta.
order.
Por cierto, no sé hace cuántos minutos estaba
And the
muteado,
team that
pero
will
yo
be
estaba
controlling
hablando
Carruthers
y estaba,
is
o sea, pero resulta
out
que estaba
in
mute. Aunque bueno,
University of California,
ahora se
Berkeley,
vendrá
the
en un
Carruthers
minuto y medio
Mission
aproximadamente la
Operations Center.
separación
There you see it
de
on the
la
screen.
tercera carga útil, básicamente el satélite
It's about a
Glide,
dozen people there.
va, el satélite, el
Spacecraft
telescopio
experts, systems
de observación
engineers,
terrestre ultravioleta
ready
Glide.
to do their part at the Space Sciences Lab, which is, by the way, perched high atop the hills on a campus, on the campus there. And they've been around 20 years, but they have one of the best views overlooking San Francisco Bay.
Yeah, it's a beautiful view. I've seen it myself.
Yeah,
It's a beautiful
it's
view.
phenomenal, isn't it?
Yeah,
Out
it's
to the
great.
Golden Gate Bridge.
Yep.
But right now, their eyes are not on
La
that view.
separación
They
está
are
programada hace más
focused
de una
on
hora,
big screens
36
in
minutos
front
y
of them.
46
They are
segundos.
off the screen, but they are looking at all the data, looking to see that sign of life that Carruthers has acquired signal. First, though, hoping to have that camera view to watch Carruthers come off the top of this stack, or the side of the stack, I should say. But it will position the second stage. That is, the second stage is putting them in position to release.
Correct, right. So recall every one of these spacecraft had a different orientation that they had to be deployed at. So the launch vehicle's already slewed to the correct orientation for Carruthers to be deployed. So mission accomplished there on that front.
There you have the second stage aiming at the sun.
Y deberíamos tener el deploy en un rato.
And they're really
O sea, en unos
moving quick
segundos,
away
en
from
10
the Earth. We're
segundos.
going 27,000 kilometers per hour. So the distance that has been put between IMAP and SWIFO-L1 is significant. We are at an altitude of roughly 5,000 kilometers.
Correct, and if you
Debería
recall,
ocurrir
we're
justo
looking at the
ahora el
altimeter
deploy.
there on the bottom right screen. We deployed SWIFO-L1 about 3,800 kilometers, and so as we're on that escape trajectory I was mentioning earlier, we are seeing our altitude steadily increase as we move to the Carruthers spacecraft also being deployed.
Carruthers, separation confirmed.
Awesome.
Y ahí tenemos deploy, misión completada
cool.
con éxito
Carruthers
del Falcon 9.
beginning its mission to capture the faint ultraviolet glow of Earth's outer atmosphere. All three released.
Yeah, congratulations to all three teams. I know this is a
Misión
big day for all
exitosa
of
por
them.
parte de
And
SpaceX.
also congratulations to the LSP team and the SpaceX teams who worked
Casi
tirelessly to
6.000
get these
kilómetros de
missions off the
altura.
ground. So kudos to all of them.
And the team for Carruthers now going to be very anxious as they look for their acquisition of signal. You know, because the spacecraft has to turn on and run a number of items, but I believe based on the reaction in the room, they may have gotten it pretty quick.
They may
Let's
have.
listen and see if we get an update to the NLM, the NASA launch manager. Unofficially, it looks like they may have got AOS, but officially, we have not heard it yet on our nets. So we may have been seeing the reaction for the spacecraft separation and
Correct.
just general excitement about making it to this point, which is a big deal.
It's a very big deal. Very big deal. Yeah, this mission was a mission where we had three payloads, and it almost was trying to be almost like it was three primaries. So I just want to give, once again, kudos to the team to getting this.
Y bueno, misión
The team looked over
exitosa
almost 500
del
different
Falcon
requirement
9.
verifications they had to get this mission off. So just think about that. 500 different
Wow.
requirements you got to verify. So,
Llevamos cuánto, 2 horas
yeah,
de directo. Sí,
big
justito
deal.
2 horas. Bueno, el Falcon 9 ha entregado 3 cargas útiles a una órbita a órbita L1 de nuestro planeta. O sea, O sea, a 1,5 millones de kilómetros de distancia
We just
de
heard
nuestro planeta. O
confirmation
sea,
from
wow,
NASA
es
launch
bastante
engineer Denton
distancia.
Gibson was given confirmation that acquisition of signal has happened for SWIFO L1.
Aunque bueno, millones de cosas.
there.
Miren esa vista del planeta.
So it looks like
A
everything was
más de
put into
6.000
a
kilómetros
good
de altura.
orbit. A great job by the second
No
stage
sé a
of
qué
the
altura están
Falcon,
ahora
Amanda.
mismo, porque nos quitaron al telemetría.
Yeah, absolutely. It has been so exciting to see the successful deployment of IMAP, SWIFO L1, and Carruthers, and already the acquisition of signal for IMAP and SWIFO L1. Now, with these successful
Esa
deployments,
vista
we
del
will
planeta
be
es
signing
hermosa.
off of our launch coverage from SpaceX in Hawthorne. You can follow NASA online to stay up to date on the 3 mission payloads aboard Falcon 9 today. Thank you so much, everyone, for tuning in, and it has been so great
Qué
to
bueno,
join you,
gente.
Daryl and Norman. And with that,
Eh,
I'll hand it back to you.
Fue un directo bastante largo, lanzamiento exitoso de la misión IMAP, puesta en órbita con éxito de las 3 cargas útiles en una órbita de transferencia de L1.
Yeah, this was a journey.
Y bueno,
This is a journey that had really
espero les haya gustado. Si les gustó, y fue así, de dejar un like. Y bueno, nos reencontraremos en menos de 24 horas. Vamos a hacer el lanzamiento del proyecto Kuiper desde la plataforma SLC-41. Será un Atlas 5. Así de que, bueno, gente, espero les haya gustado el directo. ¿Y de qué trata el proyecto IMAP? Bienvenido, Matías Díaz, al directo. Antes de que me despida, te explico un poquito más o menos de este lanzamiento. Básicamente se lanzaron 3 cargas útiles. Entre ellos estaba IMAP, de que vendría a ser la carga principal, o sea, la que denominó el nombre de misión. Después se encontraba un satélite meteorológico, de que será operado por la NOAA. Y una misión de investigación liderada por una universidad en California. Básicamente, IMAP estudiará los límites de la heliosfera, la burbuja magnética que protege nuestro planeta de la radiación. Después tenemos el satélite de la NOAA, de que básicamente observará continuamente el viento solar y las partículas energéticas que se dirigen hacia la Tierra. Su misión principal es anticipar tormentas solares que podrían afectar las comunicaciones y redes eléctricas. Y después tenemos el estudio de la Universidad de California, de que básicamente es una misión de investigación que estudiará la exosfera terrestre observando la luz ultravioleta emitida por los átomos de hidrógeno. Su objetivo principal es entender cómo responde la atmósfera superior a los cambios provocados por el clima espacial. Mira esta imagen en nuestro planeta. SpaceX, compartime después una imagen en limpio, un video, imagen o algo de esta vista porque es espectacular.
And how does it feel to be part of the space weather enterprise with IMAP on SWIFO and Carruthers all going out there? How does that feel?
Well, it feels special. I mean, in LSP, we do get to launch several different varieties of science spacecraft. Sure. But we do like some that we have repeat customers, and our NOAA customers, we love working with those guys. Anything that deals with space weather, it touches all of our lives. Exactly. And in LSP, we love supporting that. I would like to say there's one special word that I would like to talk about of a unique team member from LSP. Mr. Michael Carney. Mike Carney has led up our flight analysis division in LSP since LSP was a program 27 years ago. Wow. And today was his very last launch before he retired.
Es increíble esa vista.
So, Mike Carney, LSP loves you. We wish you the best in your next chapter. Thank you for everything.
Pues ahí tenemos. En menos de 23 horas tenemos otro lanzamiento que será de Proyecto Kuiper.
So immediately what's next for us is on our full InSight mission assurance contract is a mission called Sentinel 6B. We'll all go out to Vandenberg, California and launch.
Aunque bueno, gente, ahora sí, me voy retirando. Espero les haya gustado el directo. Y nos reencontraremos mañana para el lanzamiento del proyecto Kuiper, que por cierto ya se encuentra programado ese directo aquí en nuestro canal. Y de que, bueno, gente, muchas gracias por estar. Y esto fue Lanzamientos Espaciales. Adiós.